Question 12d. The displacement of a particle moving along the x-axis is given by x equals t cubed over 3 minus 2t squared plus 3t, where x is the displacement from the origin in meters and t is the time in seconds for t greater than or equal to 0. Part 1. What is the initial velocity of the particle? The first step is to find the equation for the velocity of this particle with respect to time. Now v is equal to dx dt, so we're going to differentiate the equation that represents the displacement of the particle with respect to time. And that equals t squared minus 4t plus 3. Now to find the initial velocity, we substitute t equals 0 into this equation. So initial velocity is equal to v of 0, which equals 0 squared minus 4 times 0 plus 3, which equals 3 meters per second. Part 2. At which times is the particle stationary? The following are the marking guidelines for question 12d, part 2. For 1 mark, we have attempts to solve v equals 0 or equivalent merit. And for 2 marks, we have provides correct solution. The particle is stationary when velocity v equals 0. So we're going to solve for t the equation t squared minus 4t plus 3 equals 0. And t squared minus 4t plus 3 represents the equation for the velocity of the particle with respect to time. And that was from part 1. Now we have a monic quadratic on the left-hand side. And that can be factorized to t minus 1 times t minus 3 equals 0. And therefore t equals 1 or 3. Therefore, the particle is stationary at time t equals 1 second and time t equals 3 seconds. Part 3. Find the position of the particle when the acceleration is 0. The following are the marking guidelines for question 12d, part 3. For 1 mark, we have finds the time when a equals 0 or equivalent merit, and for 2 marks, we have provides correct solution. The acceleration a is found by differentiating the velocity of v with respect to t. So a is equal to dv dt, where v is equal to t squared minus 4t plus 3. And that was from part 1. So a is equal to 2t minus 4. And we want to find t when a is equal to 0. So solving the equation 2t minus 4 equals 0, we get t is equal to 2. So the position of the particle at time t equals 2 seconds is found by x of 2, which equals 1 over 3 times 2 cubed minus 2 times 2 squared plus 3 times 2, which equals 2 over 3. Therefore, the particle is 2/3 of a meter to the right of the origin. The following is the feedback from the Marking Centre for question 12d. Skills addressed: having a clear understanding of the difference between differentiation and integration and their use, and having a clear understanding of the meaning of the term stationary. Areas for students to improve include solving quadratic equations, ensuring that they fully answer the question as many students only found the time when the acceleration was 0, and accurately substituting and evaluating expressions.